So here we are. Today our chapter is current, electricity. So basically you see a closed path of the here that I made. Basically this is a bulb. Basically this kind of a diagram you have seen earlier in the classes, in earlier classes. This is actually a circuit. What circuit is? Basically, definition wise, if you want to say, then it is, one second, continuous and close path through which current flow. Basically current flow or electric charge flow. Basically this kind of figure that we show is a continuous and closed path which current flows, or this is called a circuit. Basically what is actually a current? Basically the rate of flow of charges. Basically a charge that flows in a closed path of the circuit is called, the rate of flow of charges is called current. So basically the rate of flow charger, basically there are electrons, as we know, atom contains of electron. Basically when we apply a battery battery at the terminals, so basically there are two at terminals, there produces voltage, the potential difference is produced there. So basically that pushes the electron to move in the circuit, and as the electron move, their produce of a rate of flow of charges, and the charge lead to electric current. Conventionally the current direction is taken from positive to negative. Why? Because earlier when electrons earlier were not known, so the initial idea was that current flows from positive to negative. After that, when we know about the electron, that actually electrons are flowing, then we actually realize that the electrons flow from negative to the positive, and opposite to its direction is the flow of current, and conventionally we find it that. So basically rate of flow of charges called current, or we can say amount of charge, amount of charge flowing through a particular area in a unit time. Basically a particular unit time when a charge flows through a particular area, or we can say the circuit, is called current. Okay, so basically if you want to extract in terms of equation, or we can say formula, if net charge, basically charge what? Positive charge, negative charge, we know about that, and the negative charge is associated with electrons, and the positive is associated with protons, or we can say that opposite direction. If we ask the direction, we can say opposite to the flow of electron. So the net charge Q flows across any cross section of a conductor in a time t, then I current through section is I equals to Q by T. Basically the charge that flow per unit time. Okay, basically that is all about the definition thing that we have to know. So basically and it's a unit, we can say about the unit is ampere. Charge Q is basically representation, charge representation coulomb, and the time is seconds, that is coulomb second inverse. And we also get a formula of we also have a equation, the finding how many electrons in 1 coulomb 1 coulomb charge. Basically charge SI unit is coulomb. So we know that one electron has 1.6 × 10⁻⁹ coulomb charge. So Q equals to N, that is the charge equals to N of electrons, that is charge. So the charge that is 1, and here and multiply 1.6 × 10⁻⁹. Transfer 19 here, and basically 6.25 in 10⁻100, and is 80. It's almost 6.25 in 10⁻18 electrons are present in 1 coulomb charge that we have get from this equation. So this is basically differentiation where we discuss about the circuit, and then the current, that's basically the rate of flow of charges. The closed path in which the current flows is circuit, and the rate of flow of charges is called current. What is the actually current? Is actually the flow of electron across a circuit, that produces the electric current in opposite direction. Conventionally we take it from positive to negative because early electron was not known, and the definition was if net charge Q flows across any cross section area of a conductor in a time t, then the I current flow through the section is I equals to Q by T ampere, and the SI unit is in ampere, that is coulomb second inverse. How many electrons in 1 coulomb? That is 6.65 × 10⁻18.